our previous video, we discussed the normal operating modes for the autothrottle. To complete our mental model, let's discuss the abnormal autothrottle modes, as well as the protection modes built into the autothrottle. This will help us to correctly choose the level of automation needed when the flight does not go as planned. We'll start our discussion of abnormal operations with an abnormal autothrottle disconnect. An abnormal disconnect occurs when the autothrottle disconnect is not initiated by the pilot or by normal sequencing of the AFCS.
An abnormal autothrottle disconnect will be enunciated by a yellow and black flashing AT in the AFCS status box and the autothrottle mode enunciator, and a repeating
autothrottle
oral alert.
autothrottle
To acknowledge the disconnect, the
Autothrottle.
pilot must either press and release the autothrottle disconnect button on the power levers, or press the AT disconnect key on the mode controller. AT hold is an abnormal mode for the King Air Autothrottle. It will activate if an engine experiences a significant power reduction or over-torque event during takeoff if the aircraft is below 400 feet AGL and the airspeed is greater than 90 knots. If AT hold is activated, it will park the power levers at their current position until the aircraft reaches 400 feet AGL. AT in the AFCS status box will flash in amber, and an amber AT hold will appear in the autothrottle mode enunciator. An oral
check power
voice alert will also sound. Once the aircraft reaches 400 feet AGL, the autothrottle transitions back to AT takeoff and resumes active control of the power levers. In the previous video, we talked about AT idle and the conditions for it to engage. If there's an issue with one of the inputs required for AT idle, it will provide the crew with an AT idle mode fault alert. This means the throttles will not retard during short final while landing, and the pilot will need to disconnect the autothrottle prior to landing. Remember, if AT idle activates for landing and does not detect weight on wheels within 20 seconds, it will disconnect abnormally.
autothrottle
During our multi-engine training, we spend the most time preparing for the event of an engine failure. Let's discuss how the autothrottle will respond during this critical phase of flight.
The autothrottle detects an engine failure as a torque difference of 1,000 foot-pounds between the engines. If an engine fails while the autothrottle is engaged, it will either disconnect or park the throttle of the failed engine, depending on whether the failure occurs on takeoff or in flight. If the engine failure occurs on takeoff and the failure is below 90 knots, the autothrottle will disconnect normally. If the failure is above 90 knots, AT hold will engage, as previously discussed. If the engine failure occurs in flight, the autothrottle will initially push both throttles forward in an attempt to maintain the selected speed. Once the system detects the engine failure, it will park the failed engine's power lever in place and enter one engine inoperative mode. One engine inoperative mode allows for all normal autothrottle modes and protections with two exceptions. First, the autothrottle will park the failed engine's power lever. Second, the autothrottle will not allow the pilot to manually select a speed within 10 knots of VMC. Once the pilot has the aircraft under control, it can be helpful to disconnect the autothrottle and move the failed engine's power lever to idle. If re-engaged, the autothrottle will keep the power lever of the failed engine parked at idle. There are two autothrottle limitations that pertain to single-engine operations. If the pilot desires to perform an intentional engine shutdown to demonstrate one engine in operative condition, or demonstrate VMC with both engines operating, the autothrottle must be disengaged prior to starting the maneuver. When coming into land single engine, the autothrottle must be disconnected prior to beginning the approach and landing. To wrap up our discussion of abnormal procedures, let's briefly discuss the emergency autothrottle procedures you'll find in the AFMS. Note that step 1 for all emergency autothrottle operations is to press the autothrottle disconnect button on the power levers. This deliberately puts your hands on the power levers to take control. Remember that pressing and holding the autothrottle disconnect button removes power from the clutch engagement. If the autothrottle malfunction is severe enough to warrant disabling the system, reach across to the right circuit breaker panel and pull the AT servo circuit breaker.
Similar to the electronic stability protection of the Garmin Autopilot, the autothrottle has protection modes to assist with safe and efficient operation.
The autothrottle will engage to prevent over and underspeed conditions by moving the throttles accordingly. This will occur regardless of whether or not the autothrottle is engaged. In an underspeed condition, the autothrottle will increase power to increase airspeed. ATV-min will display in the autothrottle mode annunciator when this protection is active. In an overspeed condition, the autothrottle will reduce power to slow the aircraft and enunciate ATV max. If the autothrottle was not engaged prior to the airspeed protection mode activating, it will disengage after moving the power levers without providing an aural alert. These protections will also respect airspeeds for gear and flap settings. The autothrottle is always monitoring torque and ITT to prevent over-torque or over-temp conditions. Torque is limited to 2,230 foot-pounds in all phases of flight, and the autothrottle will make adjustments for RPM changes. The maximum allowable ITT is configurable and is set on the flight plan FMS en route page. If one engine reaches the operating limit before the other, the autothrottle will limit power on the more efficient engine to match the less efficient. For takeoff and go-around, the autothrottle will supersede the selected ITT limit to ensure engine power is not limited during the initial climb. If the autothrottle is disengaged and is approaching an engine over-torque or over-temp condition, it will engage to reduce power and enunciate AT max power in the autothrottle mode annunciator. To disable the autothrottle electronic stability protection, or ESP, press and hold the autothrottle disconnect button for 5 seconds. A confirmation message will pop up once the autothrottle ESP is disabled. The protections will be re-enabled when the autothrottle is re-engaged or power is cycled to the avionics. If both autopilot and autothrottle stability and protection are disabled through the system setup page on the MFD, they will be disabled until selected on again, or power is cycled to the avionics.
While electronic stability and protection, or ESP, is primarily a function of the autopilot, the autothrottle can assist with ESP recovery and emergency descent mode.
If the autothrottle is active when ESP activates the autopilot in level mode, the autothrottle will continue to track the speed target prior to level mode activating. The autothrottle will not automatically engage with the activation of level mode. When emergency descent mode, or EDM, activates, the autothrottle will engage if not already engaged. It will activate in AT descent and pull the power levers to idle. At level off, it will target the speed selected by the speed selector switch, either the manually selected speed prior to the descent or the FMS cruise speed schedule.
This concludes the abnormal operations and protections video of the King Air Autothrottle series. You should now be able to identify the abnormal modes and the built-in protections of the autothrottle and be able to state when they will activate.